Good morning, all of you. Today we're going to start with a new chapter that is Euclid's geometry. And what we are going to learn today is contribution made by Euclid towards geometry and what ideas he had and how he has made geometry more interesting and little simpler. So in this chapter you will find, since it is geometry, so geometry basically we have done in lower classes, and we are already familiar with certain simple things like point, line segment, and how to define them, and what we mean by plane or a surface, what do you mean by area, and also certain things about angles. Then we come up to two-dimensional figures, three-dimensional figures, and so on. So what Euclid meant when he started with this was like certain definitions given by Euclid, and which made geometry even simpler. And there are certain aspects of his geometry which we leave undefined because you cannot explain it any further. So you'll find, to begin with, you have some Euclid's definitions, axioms and postulates. So his basic definitions are, to begin with, now he says that suppose we take any solid object. So for example, if you take a cylinder, so in a cylinder what you find that it has this base, which will also be a spherical part, then height, radius, and this top part is also spherical or a circular region, depending what type of cylinder it is. So if we see the surface of the cylinder, then you can take the surface as one base. Surface is also the curved surface area. Top part is also the top area. So all these are surfaces. What these surfaces do now? Now these surfaces go to the lines. So like this is a solid shape. This has surfaces. Surfaces will have lines, and then these lines end with points. So finally they are ending with what over here? Points. So from here Euclid began explaining various things about geometry. First thing he spoke about is a point. So if you mark or put a point anywhere on a plane surface, as you can see, it's a point. This has no area, no shape, no length, breadth and height, nothing. So we cannot explain it to be a part of something or anything. Point is just a mark on a paper and has no dimensions here. And this point has no parts. Like otherwise we take any other shape or figure, they all have parts, which you also called a segment. But then there is a point is such thing which has no part. Then he came to a line. So from a point we got a line. So what can you say about line here? Now he says this line has only length, but this line will have no breadth. So this is a breathless figure, that means it has only length. Then he says the ends of these lines, that is the end, these are called the points. So if from a point we made a line, line has ends as points, which means this line, particular line, is made up of many points. So this is what we learned in some lower class, that a line consists of infinite points. Then a straight line is a line which lies evenly with the points on itself. So many points are here and they'll all lie on the line. Put together it gives us a line. Then a surface is that which has length and breadth only. So if you take the bottom surface of this, it will have length and breadth. Any surface you take, like this board only I take, it will definitely have a length or a breadth. Any object kept on a plane or on a floor or anything that occupies space will definitely have length and breadth. Then the edges of a surfaces are lines. So if I take the edge of this, it's made of lines. Lines end with points. So from a point you go to line. Line has endpoints. Then these lines gives rise to surfaces. Surfaces gives rise to a solid shape. Then after talking about all these things, Euclid also gave us two different terms, that is postulates and axioms. Postulates, and the second thing he spoke about is axioms. Now postulates you will find only in geometry. So these are statements which have proof to an extent or may not have. Axioms are not restricted only to geometry. They can be used in all parts of mathematics. So some of the axioms which Euclid have given to us is, the first one is, things which are equal to the same thing are equal to one another. I repeat again, things which are equal to the same thing are equal to one another. This was the first one. The second he says is, if equals are added to equals, the wholes are equal. Equals are added to equals. So if suppose we are given that A is equals to B, we are also told that C is equals to D. Equals are added to equals. So if now we are going to add A plus C is equals to B plus D, this result, sum of these two, will always be equal to the sum of these two. So if equals are added to equals, then definitely the wholes are also equal. Then if equals are subtracted from equals, the remainders are equal. Likewise, if instead of adding A plus C, now if we are going to write A minus C, this is equals to B minus D. So this difference will definitely be equal to this difference, because A equals B and C is equals to D. That is why. Then things which coincide with one another are equal to one another. Now coincide also means overlap. So for example, if you have a line segment AB, this length is 3 centimeter. Now we have another line segment PQ and we keep it on top of this. In other words, we superimpose it. Then definitely one overlaps the other, which means they have to be equal. So like you take a book, keep it on another book, two maths books, one on top of the other, they overlap. Then two say your pizza of the same size, keep one on top of the other, they overlap each other. So if the objects have the same dimensions, definitely they will overlap each other. Then the whole is greater than the part, definitely. So if you take your rectangular Cartesian system, or you take a circle, in this we draw the two diameters. So now this is divided into 4 parts. Now the total of these 4 parts will give us the circle. But if you take one portion, definitely the whole is always bigger than the part. Or in other words, a part is always smaller than the whole, both ways. Then things which are double of the same things are equal to one another. Things which are double of the same things are equal to one another. So if I know for sure that A is equals to B, then twice A will always be equal to twice B. You double both sides, again they will be equal. Then things which are halves of the same things are equal to one another. When the doubles are equal, then their halves are also equal. So what all we learned today, that Euclid started from a point. From a point he gave us a line. Then these lines gives rise to surfaces. From surfaces we go to solids. Then we spoke about what are postulates and what are axioms. Postulates are used in geometry. Axioms are used all over mathematics. Then some of his common axioms which we have spoken about here is what I read. There are 7 points. We can see in the book also. Then the next thing that we learn here is he has given 5 postulates. These are all his axioms and not in any particular order, but he has given 5 postulates. Now, the first postulate that he says is a straight line may be drawn from any one point to any other point. So, if you are given 2 points on a plane, for example, I'll repeat the axiom again. It says here that first postulate is a straight line may be drawn from any one point to any other point. So if you this how he has with the help of an axiom he has given us the result. He says given 2 distinct points there is a unique line that passes through them. So if you have 2 points, I have these 2 points P and Q. So draw all possible lines through P. We draw all possible lines through Q. But there is only one line which will pass through PQ. That is only one line. All the other lines individually will pass through P. It will pass through Q. But there is only one straight line which we can draw passing through both P and Q. That's what he says here. Given 2 distinct points, there is a unique line. Unique line means only one line that passes through them. Then the other one is a terminated line can be produced indefinitely. So in lower classes we are taught about line segment. So when we are taught about line segment, what are we told? That it is a line segment. Segment means it is a part of the whole. So if this is a line segment, then what is the whole here? Whole means I can extend it on either side. So this becomes a line. This is a line, say L, of which AB is a part. So we call AB to be a line segment. Then the next is a circle can be drawn with any center and any radius. Obviously you can have a circle here. This has some center, this has a particular radius. You can draw another circle which has a center here with another radius. So we can draw any circle with any center and any radius. Then all right angles are equal to one another. So for example, as I took a circle here, if we draw the 2 rectangular quadrant here, so you will find that you have 4 parts. Everywhere, since these 2 lines are perpendicular, these are 90-90. So all geometrical properties are filled here. 2 intersecting lines, opposite angles are equal. So a right angle is always equal to a right angle. Then the last postulate here is that if a straight line falling on 2 straight lines makes the interior angle the same side of it taken together less than 2 right angles, then the 2 straight lines, if produced indefinitely, meet on that side on which the sum of the angles is less than 2 right angles. Now this I'll explain it to you. It says that if you have 2 lines and they are not parallel. So suppose you have these 2 lines. Now these lines are not parallel to each other. You draw a transverse. Now you have some angles here. Say this is 1 and 2. You have some angles. These are also angles that are 3 and 4. Now what the postulate says is that since the sum of these 2 angles, they are both less than 90. So their sum is also less than 180. Now if these lines are extended, definitely they will meet at a point. Whereas on the other side, if I extend these 2 lines, they will go away separate from each other. So if you read that part again, it says if a straight line, that is this straight line, see this is L, M and this is Q. So if this straight line Q falling on 2 straight lines, that is L and M, makes the interior angles on the same side of it taken together less than 2 right angles. These are the interior angles. If I take the sum of these two, it should be less than 2 right angles. 2 right angles means 180. So sum of these two should be less than 180. 1 plus 2 less than 180. Then in this situation, if these are extended, then the side where it is less than 180, only on that side they will meet at a point, and on the other side they will get diverged. So this is also explained very nicely in your book. Then you have a system of axioms which is called consistent. Then there are some prepositions and theorems as it goes on. And after this you have some solved examples in the book 1, 2, and then there is a theorem 5.1. Now this theorem says two distinct lines cannot have more than one point in common. Two distinct lines cannot have more than one point in common, which means if I have two lines anywhere and I have to make them intersect, they can intersect at only one point. They can never intersect at more than one point. So you have, suppose we assume that these two are intersecting at two different points. Say one is P and suppose there is another point Q. They are intersecting at 2 points P and Q. So what will happen now? Earlier what did we say? That if there are two distinct points and you draw number of lines passing through these, you find there is only one line which will pass through both these 2 points. Only one line. That concept will come back here. If these two lines are intersecting at 2 points, then what will happen? There are many lines passing through P, many lines passing through Q, and so that means there has to be another line drawn like this. But we know this is not possible here. So if you have more than that, then it clashes with this concept here. Whereas according to this is not possible. Hence what we assumed is not very correct. So if there are two lines, their point of intersection is only one and only one. So children, please go through. It's a little theoretical chapter and a very easy one. Then after you've been through all this in your notebook, please write all the postulates, axioms, and then postulates with the statements, and also this theorem 5.1. This also you write in your notebook. After you've written all these things, then you come to the exercise, which we'll discuss it when we have a class or as and when we meet. So for the time being now, what you will do, begin the chapter and go through all its definitions, that is point and line and things like that. We are already familiar with all these terms. Only these two terms are new, postulates and axioms, and certain things are new to us, but I am sure as you read it, you will understand what it is. So please go through it, write all this in your classwork notebook, and only after that you will come to the exercise. Thank you, guys.